Okay, now we're looking at number 4 for the Common End of Course Exam Study Guide. We've got a perimeter problem here. Number 4 says a wooden fence is to be built around a 50 meter by 62 meter lot. How many meters of fencing will be needed? If the wood for the fence costs $47.75 per meter, what will the wood for the fence cost? Okay, so we're given the length and the width of a field or a lot, and so if we can find the perimeter, we know the distance around that lot, and we'll know how many meters around that lot, and then it's $47.75 per meter. So we can multiply the perimeter times the cost per meter. So we have looking for the perimeter. We've got two sides that are 50, so that's 2 times 50, plus two sides that are 62 meters long. Okay, so 2 times 50 is 100. 2 times 62 is 124. 100 plus 124 is 224 meters. So we have 224 meters, and so the cost is going to be 224 times the $47.75. Cost per meter is how many meters we have. So we multiply them together, and let's see, what do we get? 224 times 47.75 is $10,696. So we see C, the perimeter, $224, and we see the cost is $10,696. That's not cheap, is it? So we have C for number 4. All right, let's look at number 5. I already have some work there. Let's go ahead and erase this and go through it again. So number 5 says Marisol is creating a custom window frame that is in the shape of a regular hexagon. She wants to find the area of the hexagon to determine the amount of glass needed. She measured a diagonal D and determined it was 40 inches. A diagram of the window frame is shown below. So we've got a window that's in the shape of a hexagon. She wants to find the area of the hexagon so she knows how much glass she needs. And what she does is she measures the diagonal of the hexagon. This is the center of the hexagon. She's going from one vertex through the center to another. So this diagonal is the diameter of the polygon. Remember, for a regular polygon, you have a center, and from the center to the vertex is called the radius. Okay? So we're going to have to find the area, and if the diameter of the or if the diagonal of the regular hexagon is 40 inches, then from the center to the vertex, that's half of that, which is 20. So we've got 20 inches for the radius, and we'll need that because what we're going to do is we're going to use our formula for finding the area of a regular polygon, 1/2 times the apothem times the perimeter. Remember, the apothem goes from the center of the polygon. Let me see if I can line that up a little bit. It goes from the center of the polygon perpendicularly to the side. All right. So we're going to have to find the apothem, and we're going to have to find the perimeter, okay, of the hexagon. So what we can do is find the length of one side and then multiply that times 6 to get the perimeter. We're going to use what we know about right triangles to find the apothem and the perimeter. Remember, since we have the center here, and when we go from the center to each vertex, we're going to have as many, oops, we're going to have as many central angles as we do sides when we go from the center to each vertex of the polygon. All right, and that, so we've got 6 sides, so we're dividing this triangle, or this hexagon, into 6 isosceles triangles. Remember, the radii are all going to be congruent, so we've got 6 isosceles triangles. So each one of these vertex angles are congruent. All right, and we need to find the measure of one central angle, so that we can again use what we know about right triangles to find the apothem and the perimeter. So we've got 6 angles that make up 360 degrees. So the central angle, I'm just going to write that as CA, is equal to 360 divided by 6, which is 60. Okay? So the central angle, each one of these central angles is 60 degrees. Now this apothem, remember, is perpendicular to the side. So remember, with an isosceles triangle, when you have a perpendicular from the base to the vertex, it's the altitude, it's the angle bisector, the perpendicular bisector, and so forth. So what we're doing is this apothem is bisecting this 60-degree angle, and so we have a 30-degree angle here. Okay, so this angle is 30 degrees. I'm going to write that out here, but that's this angle here. All right. Let me see if I can do that better. So this angle here is 30 degrees. And we know that this one's 90, so 30 and 90 from 180 is 60, so this is a 60-degree angle here. We need the apothem, and we need the perimeter. We have a 30, 60, 90 triangle. We only have one side length, so we can't use a Pythagorean theorem to determine the length of the apothem or the side. So what we're going to have to use is our special right triangle theorem for 30, 60, 90. All right, and let me stop and put that up here. Let's see, let me pause here. Okay, so we're back here with our illustration for the theorem for a special right triangle for 30, 60, 90. And we see that the shorter leg, if we call it x, then the longer leg is the square root of 3 times x. Remember, the legs are the two sides that form the 90-degree angle. And the hypotenuse is twice the shorter leg. So let's start with, here's the 30-degree angle. So the shorter side is going to be opposite the 30-degree angle. Let's start with the shorter leg. The shorter leg is going to be half. If the hypotenuse is twice the shorter leg, then if we take half of that, that's going to give us the shorter leg. So that's 10 units. Okay, and then the longer leg is the square root of 3 times the shorter leg, so that's 10 square roots of 3. Okay, that's the longer leg. All right, so now we can find the perimeter, and the area, or the apothem, we know is 10 square roots of 3. Okay, so the apothem is 10 square roots of 3, and then the perimeter is going to be, if we double 10, that's going to be 20. Okay, and then 6 times that, so we have 6 times 20, which is equal to 120, and we're talking inches. So now we're ready to use our formula. All right, so let's do it over here. Area is going to equal 1/2 times the apothem, which is 10 square roots of 3, times the perimeter, which is 120. So when we use our calculator, we're going to estimate here. So we have, I'm going to do 10 square roots of 3 times 120 times 0.5, and I get 1,039.2 square inches approximately. Let me change this into an approximate symbol. We have 1,039, and do they tell us where to round? In the nearest square inches. So we've got 0.2, so that's going to round to 1,039 square inches. Alrighty.